Okay, so today we are going to go, and I'm going to make 3 separate videos, page 1, page 2, page 3, for the 9-week review. This is really getting you prepped and ready for your final exam review. So for this first one, it is implicit. 3x squared plus 2y. Oh, but wait, it was a y, so we need y prime hooked onto that. Equals, and the second one is a product rule. Oops, I want that in blue. Let's put that in blue. And then my first term is 5x. The derivative of the second is y prime added on to the second term is y times the derivative of the first would be 5. So 3x squared plus 2y y prime equals my 5x y prime plus 5y. Okay, so get everything with a y prime on the left side, everything else on the other. So my 2y y prime is going to be subtracting a 5x y prime. And then on the other side of the equation, I have that positive 5y, and now it's going to be subtracting my 3x squared. Get the y prime by itself, and by factoring it out, 2y minus 5x equals the 5y minus 3x squared, and finally the y prime, oops, wrong color, is going to equal my 5y subtract 3x squared, all divided by 2y minus 5x. Okay, implicit. You guys should remember how to do that. We've been working on that lately. So another implicit. I am going to power down 2 over 3. I powered the 2 down. That's how I got 2/3 x plus 1 over 72 when I brought that down y. Oh, but it's a y, so it needs a y prime hooked onto it, is going to equal 0. So my y prime, I'm going to do a lot of work here in my head, is going to equal a negative 2/3 x, and that's going to be multiplied by 72 over y to get rid of this. And my final equation would be y prime equals, and I believe, does 3 go into 72? Yeah, 24 times. I'm going to get negative 48 over y. But now, oops, negative 48x over y. Now I just need to plug in my values, which is going to be negative 48 times 1 all over square root of 240. That's my slope. So y minus my y1 value equals my slope of negative 48 over square root of 240. X subtracts 1. Done. Okay, into the fun stuff. I love these. So these are our related rates. Remember, change means derivative. So if the radius is increasing at a rate, that is my dr dt. And it wants me to find out how fast in cubic inches. That tells me that it's a dv dt. That the radius is when it's an 8. So I start off with my equation, 4/3 pi r cubed. I take the derivative with respect to time. So I'm writing that one out for this first one, so you can remember. So I get dv dt would equal the 4/3 and the pi are coefficients. Now 2 times r dr dt. So now it's just a matter of plugging in the numbers that you know versus the number you want to find. I want to find dv dt. So I have 4 and pi and 2, and the radius is 8. And I have to apologize. This is r cubed, this is a 3, this is a 3, and this is squared. And I know that my dv dt is, lost it, 3. and this is all over that original 3. These 3's cancel. I'm left with 4 times 12 times 64, which is 768 pi, and that would be in inches cubed per second because it's a rate. Sorry about the math there. This is a cubed, this is a 3, that's squared, so that's a 3 and it's squared. Okie dokie, second page, part of the first page. So, taking a look at the next type of related rate problem, that is a ladder problem. So you guys need to remember, here's the house, here's the ladder. When you read it, the ladder is 30 feet. It is being pulled away at a rate of 5 feet per second. That is a dx dt because it's going left and right. It's asking how fast is the top of the ladder moving. That is a dy dt. And the specific time, the snapshot, is when x equals 10. And then we can figure out y, and it says round your answer to 2 decimal places. Okay, so some things that you need to remember. X squared plus y squared equals z squared is the function. And in particular in these, if something is never moving, the x squared plus y squared, the length of the ladder would never change. We plug that in before we take our derivative. So we take our derivative with respect to time, and we get 2x dx dt plus 2y dy dt, and it equals 0. Everything is divisible by 2, so I'm going to get rid of that. Now it's just a matter of plugging things in, but the one thing you need to remember is you, at that instant, I know this is 10 and this is 30, and if I do Pythagorean theorem, I can figure out that this is the square root of 800, and I'm not going to change it from that. So when I come in here, I get my x value of 10, my dx value is 5, added on to my y value is square root of 800, and I'm looking for dy dt, and it's going to equal 0. Okay, so my dy dt is going to be negative 50 divided by square root of 800, which turns out to be negative 1.76, and that would be feet per second. And last one, because of space, and I promise you will have more space on your test. This, oops, wrong kind of cone, is a cone vertex up or a cone vertex down. So this is vertex down. They told us that the all the way across the cone is 18, so that means it's 9 and it's 12 feet deep. And right away I know R compared to H would equal 9 compared to 12, or 3 compared to 4. So 4R would equal 3H, or R would equal 3/4 H. I'm going to use that to substitute in to my equations. So if the tank of water is flowing at a rate of 20 cubic feet per minute, that's a dV dt, find the rated change in the depth, that is a dH dt, when the water is h units tall. So when, with my equation, volume equals 1/3 pi r squared h. I can't have r in here because notice this is h dh, blah blah blah. So volume would equal 1/3 pi. Radius gets replaced with the 3/4 h squared h. So volume will equal 1/3 pi 9/16 h cubed. Now, just doing a little math, this 3 and this 9 will reduce. But that's my equation. So now I need to take the derivative of that equation. dV dt is going to equal 3 pi over 16 times 3 h squared dh dt. So I kind of move some things together. Plug in everything we know. We know the 20 is the dv dt, the 3, the pi, and the other 3 stay on top over the 16. The h would be 7 squared, and I'm looking for dh dt. So dh dt is going to equal 20 times the 16 is now on the top, the 3, the pi, the 3, and the 49 are on the bottom. And when you work that out, it should be 320 over 441 pi, and that would be in feet per minute. Okay, good luck on, that's page 1.